Hey guys, Arpit this side. It's time for yet another C Python internals deep dive, and in this one we'll be talking about strings in Python. More specifically, how Python optimizes strings in general. Like always, we'll be exploring C Python code base and finding out how it actually does that. So in this one, I am using the latest pull from master branch of C Python, which is right now working with version 3.10. So if you are following along, ensure that you are working on version 3.10 and have a similar code base there. There won't be a very major changes, but it's better to have a like-to-like version. So since we're talking about Python, let me create a new string called the honest Python. A shameless plug I've added, but that's okay. I create a equal to the honest Python. I'll create b equal to the honest Python again. Now when we do a double equal to b, what it would do it is, if this is implemented using strcmp like very basic functionality, it would go through character by character and find out if strings are equal or not. But Python does something much more beautiful. So in Python there is this function called id. What it does is it returns an identity of the object. If it is C Python, it uses object's memory address. So you can treat the return value of id of a as the memory address where a resides. So memory address where a actually points to. So basically where the string resides. So it's 43432449712. Now when I do id of b, you'd find that they are exactly same. It's also 43432349712. Right, so id of a is exactly same as id of b. What does this imply? This implies that my variables a and b both are pointing to the same memory address. Right, this is very interesting because now even though we specifically initialized a as the honest Python, b as honest Python, Python instead of allocating a separate memory space for the honest Python as my second wala honest Python, it reused what a already pointed to. So it somehow identified that this string already exists and it needs to use the same reference here, right? And this sort of optimization is called string interning. It's more like you can think of it like we are actually caching strings, right? Where is this helpful? Now when you do a double equal to b, Python, instead of going through the strings one by one, or instead of going through characters one by one, it can first of all like immediately check if a and b point to the same address or not. If they do, then strings are definitely equal. If not, as part of fallback, it can obviously go through, and it should actually go through character by character. But this is very interesting. It makes lookups really faster, right? It makes your equal comparison really fast, right? So since this optimization is called string interning, in Python under sys module, you can explicitly ask Python to intern any string, and it's present as part of sys module. There is this function called intern, sys.intern and intern, and when I call help on that, you get the help string, help text of that. What it says is intern function enters the string in the global table of intern strings. More like cache, where you are dumping in all the strings and you are using it to pull that if the string exists, I'll use the same reference, otherwise I'll create a new string in that space, like whose purpose is to speed up dictionary lookups. So in dictionary lookups, having text key is the most common use case, and optimizing key lookups, since dictionaries are so heavily used in Python, optimizing key lookups would actually make the overall language like really fast. So that's where string interning plays a very major role. So given this thing, let's find out what it does internally. So we know that it's part of sys module as intern function. Let me open code of sys module. I open this. Around line number 903, you'll find a function called sysintern impl. Going by the name, it really looks like it's an implementation of sys.intern, right? So this is one of the main reasons why I love C Python codebase. It was so intuitive to just go through and understand things. It's fun. So sysintern impl, let's see what it does. It checks if my string object is actually a string or not. If it is not, it raises an error which says can't intern, because you can't intern non-string objects. So you can only intern string objects. So there is this check if PyUnicode exact for PyUnicode, which means if S is Unicode, then it would go within it. does some increment reference, more like garbage collection. So now more things are pointed to it, something like that. And then it invokes PyUnicode intern in place. This is the main function that is responsible for interning the strings. Like, because in this thing there is nothing else than this, right? Other thing is just checks and all. So PyUnicode intern in place is the one that performs all the string interning. Let's check its implementation. So now over here it accepts pointer to a pointer, not a single pointer to something X, but a pointer to the pointer to Python object. And then what we create is we create S out of it by dereferencing it once, and why it's taken pointer to pointer will get that reasoning down below. So now it has taken S. What it's doing is some routine checks, ensuring that it is obviously Unicode. And here what it is doing is it is checking if my PyUnicode is actually interned or not. If it is already interned, then I don't really need to re-intern it again, right? I can like directly return. So it saves us bunch of computation. It checks for readiness of Unicode. It would be something, I don't know the internals, but that's okay. This is something, so basically this is where the fun things begin. So what it does is it get Unicode state. Let's see what it does. I'll open the GetUnicodeState function and we'll see what it does. What it does is it gets PyInterpreter state, looks like global interpreter state something, and within that it returns memory address of arrow Unicode, more like Unicode specific interpreter state it has returned. So this is like that global table that help text was talking about, where it's dumping all the intern string. It looks like we are closing on that. So that global state is obviously Unicode specific because string interning, and what we do over here is what we see is that state arrow intern. So in interpreter state arrow Unicode, arrow interned is pydict new. So it's creating a new dictionary type and allocating it to interned. So this is the global table that the help text was talking about, and in this one, if this is not initialized, if this is set to null, matlab if it is not initialized, we are initializing it with a brand new dictionary. With this brand new dictionary, what does this mean? That the global table is implemented as a dictionary, right? Fine. If state arrow interned is null, more like error condition, that even after invoking this, if we were unable to get a new dictionary due to out of memory issues and all, it would not do anything, not throw any error, because you would not want your program to crash. Now comes the most interesting part of it, on how it actually implements. So what it does is it does pydict underscore SetDefault. So Python dictionary has this function called SetDefault. That function, what it does is given a key and the value, it checks if the key is present in the dictionary or not. If it is present, then it would return the value that is already set in the dictionary. Okay, but if the key is not present in the dictionary, then it would take in the value that you have passed in as the argument to SetDefault and set it in the dictionary, right? And obviously it would return the value that was set. So if the value is already set, it would return the already set value. If the key is not set in the dictionary, it would set the value in the dictionary and it would return the same value again. This is something that string interning exploits beautifully. So now here what it is doing is, so in pydict SetDefault, it is setting key as S and value as S. So key and value both are passed as same S object. You'd think that this is very expensive because you're storing strings, but in reality you are not actually storing strings. What you are actually storing is actually a pointer reference. So you are just using just 4 bytes of key and value space and not like storing entire string in the dictionary. So you are doing state arrow intern. So you are calling SetDefault on state arrow intern as in your global table with key as S and value as S. Let's see what's happening over here. So let's say if S does not exist. Okay, if S is not existing, what your SetDefault function would do is your SetDefault will set. So over here, while doing this SetDefault, what it would have is, while doing this, what it would have is, it would use the first s as the key, and the second s is more like value, is more like the default value that you have to pass in. So if key does not exist, then it would use the default, value that would be set in the dictionary. So it beautifully exploits this particular thing. So what it would do, it is if s does not exist, if s as key does not exist in the dictionary, then the set default will set what, s colon s, where the first s is the key and the value is again s, because here we have passed in as s, and it would return s, which is the value, right? What's really interesting about this is, since it's basically returning the object that is set in the dictionary, right? So it was trying to set s. If the s does not exist, then it is setting s colon s in the global table and it is returning s. Okay, this s is nothing but the first instance of the string that we have seen. So if I was playing around with the string, the honest Python, then in the dictionary what it stored is the first instance of string the honest Python, right? Now what would happen if s already exists? Now if s, which is key, already exists in the dictionary, now according to the set default functions logic, what it would do, it is, it would, instead of setting, it would return the already set value. So now with this what it would return, since the key already exists, then the value against it is the first instance of that string. So then it would return already set value, which is the first instance of the honest Python, right? So the logic here is really interesting. So it is playing around with the return value of set default. So if the return value of my set default function, if the return value of my set default function is stored in a Python object t, and now if, what would happen if this object t is same as s, is same as this s, my default object that was passed in. So if t double equal to s, right? So now what would this imply? This would imply that key did not exist, the default object that was passed to it was set and returned. So if t double equal to s, it implies string did not exist, as in string was not interned, and we have to intern it, right? Else, as in if t is not equal to s, it implies string already interned, so do nothing, right? Because string was already interned, right? So if string is already interned, then what I would have to do, it is, I would want to basically reuse the returned instance, because returned instance is the first instance, right? Returned instance is the first instance of the string, correct? This is a gold logic. So now this is something which is exactly translated in the code. So if t is not equal to s, as in this particular else logic, so what it does is it increases reference, because now it understands that more users are pointing to it, so it would increment the reference to that particular object. So over here it's using t. T is what? T is the first instance of the string, right? So it is increasing its reference, and this is the most critical statement. It does a pi set reference and it sets star p to be equal to t. It means, so this is why the function accepts pointer to a pointer, not just accepts pointer to just intern that particular string, but it accepts pointer to the pointer, because it wants to make a change in where it is in the variable that was passed in. Because what we saw was, when we did id of b, it gave us the same address, right? Basically it is manipulating the variable which is passed, and this is exactly what needs to be done. So what it does is, it increases the reference of my first instance of the string, and it sets star p to be equal to t. So it's making the change in the variable itself, that now it would point to what? To the first instance of my string. This is where that magic happens. This is where the honest Python string for B, for the second statement that we have given, it identifies that t is not equal to s, and over here it would do a set reference. So let me just add a printf statement over here. What we saw was this t not equal to s would happen when string is already in, string is, let me put it shorter, already interned, and I put a percentage s. Let me just print out string, and I'll do a py unicode as utf, and I'll pass in s. Okay, no, sorry, t is already this thing now, so let me pass in t. Okay, so what it does is already interned. We are printing already interned py unicode as this, and if this is not the case, as in my code went over here, and obviously while when it is already interned, it has to do nothing. It just sets the reference, so it says star p equal to t, and it returns off. So if my flow comes over here, it implies my t is equal to s. When t is equal to s, it implies string did not exist. So string did not exist means it needs interning. So it would have set the first instance in the map, in the global table, and then it would have returned. So which means in that same state s, in the same string object s, it needs to set intern to be true. So it sets intern to be equal to s state interned immortal. So more like some state or 0, 1, 2 would be there, that it does something. So if I put a printf over here, we'll look into what s state interned mortal is, but let's first ensure that we are that our hypothesis is true. So what we want to do is we want to interning a string s, and I'll use the same flow over here, and I'll print s. So if this hypothesis is true, for the first thing it would have to say interning the string s, and if it was, and for the second one it should say already interned, right? So now if I call make, I build this code, I call make, and what I'll get is, let me just let it just build the entire object and the binary. See, it already started printing already interned, but we'll see this in detailed action now. Now what I'll do it is, I have my, see, so many interning calls happen when my it start. Now that we have added printf, we can see how many times it gets invoked. So I'll just copy paste this string, and let me do this. I'll set a equal to the honest Python. What it should do? It should say interning that particular string. It said interning the honest Python. It said already interned for other strings, which is stdrr, flush, and stdout. That's okay. So for that thing, it came to this particular place. But for the string that we are interested in, which is the honest Python, it came out over here. But now when I do b equal to the honest Python, it says already interned. Basically, it went into this flow. It says already interned. It changed the reference, and then printed this particular thing, and it returned. Got it? This is how string interning actually happens, and this is where the magic happens. This is where it is doing star p equal to t and changing the reference and reusing the first instance of the string. Now, one thing that we missed on is dot interned. Now what is this dot interned? It says py unicode state s, so something like changing the state of something of my py unicode object, which is s, of dot interned to something. Let's just hit on dot interned. What do we get? So if I click on dot interned, we would get to something. Yeah, we came over here. So this is some chunk. So this is part of a struct, something of ASCII type. So it works only for ASCII something, or it might just be the name. It has py object head, py is size t length hash. It has another struct. Struct has name state, which is where it's doing. So py unicode state, it would be referring to this, and within that is referring to interned, right? And intern is taking just 2 bits of space. So within that state, within that struct, it is doing bit slicing, and what it's doing is it is using 2 bits of space to store if this string is already interned or not, right? And the value of this interned is what? State not interned. So there are 3 possible values. 0 implies it is not interned, 1 implies it is interned but mortal, 2 2 implies it is interned but immortal. Looks like immortal implies it cannot be deleted and mortal implies it would be deleted and something like that. So given this interned and not interned, now we understand how it is, where exactly this information is stored. So given this, now what would our stuff be? So the remember we encountered this particular function where it checked intern. This function should act, what it should be doing is it should be going into the state and should be checking if state.interned is non-zero or not, right? So if I click this and I check, it's doing exactly that. It's converting OP into PyASCII object and using state.interned to find out if it is interned or not, right? And this is how string interning is happening, right? This is really cool, right? Now what? There is something much more fun than this. What we'll do it is, let's see what happens if I try to intern another string. I'll say Arpit's the honest, or let me change this string to the space honest space Python. Okay, now I'll do b equal to the space honest space Python. Now if I do id of a equal to id of b, it gave out false. What does this mean? This means that this string is not interned. Achha, by the way, before this, let's have some fun. What if I would want to print if a string is interned or not? Like for example, if I have string a and when I do a enter, it should also print if my string is interned or not. Okay, let's do this fun thing so that it would help you guys understand on how to like think about making changes. So what happens when we do a and enter? It basically prints out the representation, the REPR of the particular type. Okay, so obviously this type is Unicode. So in Unicode.c you need to have that REPR function, right? So let's just do a control F of REPR, and since it's a function, should end like something like this. Does it have Unicode REPR wrapper, Py object wrapper? So something similar should be there for Unicode. Let me check for Unicode REPR function. Yeah, here it is, Unicode REPR. Yep. So when you do a enter or any string variable enter, or what it would internally be invoking is the REPR of it. So this REPR is for any Unicode object, and over here what we would do it is, this is where it does all the it actually converts it into string format and passes it to be printed. So at the end of this function, what I would do it is, I would do a printf. Of is intern, and I'll put a %d/n, and I'll do I'll do py check. No, what was that? It was something check intern, right? Check PyUnicode check intern. So I'll invoke that same thing on object. What's that object that it got? Let's check for the argument what it got. Argument. It got Unicode. Achha, Unicode is the name of the argument. Let's put this. I'm not sure if this is going to work, but let's check out. I've put in Unicode, PyUnicode check intern, and let me run make again. Oh, semicolon. I'll run the make again and see what happens. So PyUnicode check intern was giving you 102 something, and it would check if it is interned or not. It would return 0 if it is not interned. It would return 1 if it is interned, right? So let it print. Okay, now I'll open the shell and chalo, I'll do a equal to the honest Python, enter. And now if I do a enter, is interned, spelling is wrong, INTERNED, is interned. It said is interned 0 because the honest Python is not interned. Okay, so now that we have done this, I think it's okay, we have put this is interned over here, and PyUnicode check intern is over here, where we pass in Unicode and it returns 1 0, or basically 0 1 2. It returns that thing, and we just print it. So now when any string is interned, let me try it with the old one, the honest Python, and it says interning the honest Python. If I say a enter, it says is interned 1, right? So this is how we have printed like is interned 1 or not, right? So it's that simple. So now comes to the next part. What's the stretch of interning, right? So let's answer that. What we saw was uh, it did not automatically intern the string the honest Python with spaces, right? It did not intern the string the honest Python with spaces. Why? There should be some logic that allows the honest Python without space to be interned and honest Python with space to not intern. So how would we identify? What we'll do it is we'll look for, we know that the crux function is what? Intern in place. I'll use this same function to grep in, and let's see, we'll only look in for star c comma star dot h files. Mostly it should be in C file because that's where the logic is. So we'll look into only in C files and see what we find. So I'll start from the top. This is more like interning dot count something, pi Unicode tuple item, it's okay. Setting in tuple something interesting. This is pi Unicode check exact does something with pickle. Pickle has nothing to do with that. Interning. Oh, this is interesting. In code object file, we got this. So it says all name characters. So it takes some v, and what it is doing is it is checking if all name chars. Looks like if everything is character or something, then only do pi code pi Unicode intern in place, right? So now let me check out this and let's see what all name chars does. If I open all name chars, what it does is it checks if pi Unicode is ASCII. If it is not ASCII, rather, if it is not ASCII, then return 0. Then you don't have to. So then all name chars is false. If it is 1 byte data, then it iterates through the string and it checks if everything is elnum or having an underscore. So what it is allowing is every character can be, or rather every character should be alphanumeric, and only non-alphanumeric character that is allowed is underscore. Given this, if all name chars would return true if every character is ASCII, or basically if every character is alphanumeric, more specifically if every character is alphanumeric with exception being an underscore, then it would return 1, otherwise it would return 0. Which means if this is how it's working, then my the honest Python with underscore should be interned. Let's check that out. I've never tried this. Is interned 1. Right? So that's the logic of how Python is trying to do string interning. Right? And obviously now if we were to change it, like we would want it to intern every single thing, what we would do? We would just get rid of that check. We would just get rid of all the things that we have found where is interning is being used, and we'll be modifying that. Right? It's that fun. So yeah, that is it what I wanted to cover around this, and I hope you guys learned something fun, learned something new. I had written a very interesting article about string interning about 5 to 6 months back, and while writing that I was more into on where exactly it's string interning being used. So I would recommend you to take this as an assignment sort of stuff, where you would want to find out what all strings does Python, because when we ran this particular, so basically when we started this python.exe, we saw it was interning in a lot of stuff, right? So what I would want you guys to do it is explore the C Python code base and find out what all strings are being interned, right? So all you have to do it is just look out for pi Unicode underscore intern in place into C Python code base and see, and just try to make sense out of it. It is a very fun exercise, and you can anyway refer to my article, which I'll link in the comment below, in the description box below. You can go through that and see if it matches yours. And although I was not that exhaustive, but it's really a fun exercise to do so. So I hope you guys had fun in this particular video. It might be a little long, but it was definitely fun for me. I spent more than three and a half hours just to understand how it's working, and then I was able to compile it into this particular thing. So yeah, basically that's it from me. If you guys like this video, give this video a big thumbs up. If you like the content, please give a big sub to this channel, and I'll see you in the next one. Thanks, Atan.